And I'm going to, so you should see a quick pause for a moment here while I pass control over to Daniel here. And Daniel, I am going to make you the presenter, and I'm going to mute. And Daniel, you are on.
Okay.
Hold on just a second. Let's just make sure that we can see. And I can see your screen. So if currently everyone, what you should now be seeing is a title page of Daniel's, which says using the geometry sketchpad to explore multiples and factors. If you can't see that, please send us a quick message in the question panel. Daniel, again, a reminder to minimize your control panel because the big black screen is there on the side there. Thank you. And I'm going to mute.
So welcome everyone to our webinar on using the Geometry Sketchpad to explore multiples and factors. I'm very excited to be doing a webinar on the elementary grades. We often think of the Geometry Sketchpad as a software for middle school and high school. But in the last 6 years or so, we've been doing a lot of work to think about how to use Sketchpad effectively in as young as grade 2. And you're going to hear at the end of this webinar a little more information about our most current work with using Sketchpad to explore number and early algebra. But today's webinar looks at exploring multiples and factors. Now, multiples and factors you may not necessarily, if you know anything about Sketchpad, think of as so visual. In fact, before I began to work with multiples and factors with Sketchpad, they weren't a topic that I was particularly intrigued with in terms of how to make them something that was visual and engaging. I wasn't quite sure how. But over the course of our work with Sketchpad and Number, we've come up with a number of very intriguing ideas for using multiples and factors with Sketchpad. So in today's agenda, we're going to be looking at several activities. Our first is Jump Along. And in Jump Along, we'll be looking at a rabbit as it jumps along a number line where you can control the number of jumps and the size of those jumps and how this model relates to factors. The next model we're going to look at is dynamic number grids. You might think of this as the hundreds chart on steroids. What would happen if you could control the size of your chart, how many numbers it showed, and the jumps that you want to take on the chart, so that you might show multiples of 3 or multiples of 4 or even 2 multiples simultaneously.
Daniel, can I interrupt for just a moment?
Absolutely.
There's been a request if you could speak up a little bit louder or get closer to the speaker.
Let me try getting a little closer.
Okay. Thank you.
Okay. So for our next activity, mystery number, we're going to combine our work with multiples and factors with some logical reasoning. From there, we'll look at a brand new activity called dancing factors, where the movement of factors on the screen tells us something about their properties. And we'll end the webinar with some resources. And we should say that everything that I'm showing you today you will get a link for. So all of the worksheets, notes, and sketches will be available for you to use with your class. Finally, I should say about these models that these are all models that have been built for you. They're not ones that are built from scratch. The advantage of using these models with elementary students and teachers is that there's really no learning curve here that they have to experience. We've use these with teachers who on day one have been able to just dive right in and use these models with their classes with no prior knowledge of Sketchpad. So the people who will be working with me today are Karen Greenhouse, our webinar organizer, and Scott Steckedy, who's my colleague at KCP Technologies. Together, Scott and I have worked on creating the activities you'll see today, and we'll tell you a little bit at the end about the project we're currently working on. So before we begin with our first model, we're going to have our very first poll. And the poll is a way for us to get you a little more involved in the webinar process. So at several times during the webinar today, we'll be pausing and asking you a question. So let's see. Our very first poll for today, and I am bringing it up now, is the following. Have you used visual models to teach multiples and factors? And we'd like you now to respond, either yes or no, and then we'll show the results of this poll as soon as everybody's responded. Okay, so if I look at the poll results, it looks like about 60% of you have used visual models to teach multiples and factors. And I'm hoping that after today that number might go up a little. So let's turn now to our very first model. Here we see a rabbit along a number line. And there are two different numbers here we see below the number line. The number of jumps the rabbit will take and jump by, which is the size of each jump. So let's look at what happens now when we have 4 jumps and a value of jump by equal to 1. I'm going to press jump along. And we see that the rabbit, as predicted, took 4 jumps. Each jump is of size 1. And the rabbit left behind the trace of its movement. So now I'm going to move the rabbit back to 0. I'm going to erase these traces. And I'm going to look at the particular task that we have here. How many ways can the rabbit jump to 12? So one way we could do that is to have 4 jumps and have each jump be of size 3. So if I want to change this 1 to a 3, I can simply go in here to my edit box, and in place of 1, I'll type 3. And now I'll simply press jump along. Let's watch what happens. The rabbit took 4 jumps, each of size 3, and as before, we see a trace of the rabbit's path. Now I'd like to think about other ways to move the rabbit to 12. First, I'll move the rabbit back to 0. And if 4 jumps of 3 worked, well, then it should also work if we do 3 jumps of 4. So I'm going to change both of these numbers and flip them. So now we have 3 jumps, each of size 4. And before I press jump along again, I'm going to select the point below the rabbit. That's the point that's tracing out this path here. And I'm going to change the color of the point so that I can differentiate the second path from the first. So I'm going to go to the display menu and pick a new color. So now I've made the color of the point blue. Let's watch what happens when I press jump along this time. Now we see 3 jumps of 4. So we see a nice example of the commutative property at work, where 3 jumps of 4 gave us the same result as 4 jumps of 3, but visually the path that the rabbit created are different. So we can continue this process. I can move the rabbit back to 0 and think of other ways to move the rabbit to 12. One way that students like is to do 1 jump of size 12. Again, I'll change the color of the point below the rabbit and press jump along. And if you thought there was nothing funny about 1 times 12, let me tell you, when students see that rabbit take that giant leap, that is very memorable and very funny for them. They just love seeing the rabbit take off like that. Of course, if 1 jump of 12 works, then similarly, we can do 12 jumps of size 1. And watch the rabbit hop along. We can continue this process now, and I won't do it here, of doing the remaining jumps that will land our rabbit at 12. So we could do 2 jumps of 6 and 6 jumps of 2. And when we're done with this, we have a visual trace of all the ways the rabbit could land at 12, what sometimes we've called a factor rainbow. And it provides a very visual model of looking at factors. Now, in this particular problem, we've asked how many different ways can the rabbit move to 12. There are, of course, many, many other values, any number along this number line, where we can ask how many ways can the rabbit jump there. So, for instance, I can go here to my text tool and simply change my 12 to perhaps, say, a 17. And some students might think, well, 17 is bigger than 12, so I'm thinking there are more ways to get to 17 than 12. But they quickly discover that 17 being prime only leaves them 2 ways of getting there, 1 jump of 17 or 17 jumps of 12. A much less colorful rainbow than they had before. We can also, rather than just go up to numbers that right now go as high as 21, drag our point here at 1 and move it to the left or right and change the scale. We can, for instance, this question came up yesterday, change the scale so that we can see 12 right here on the number line as the target that we were trying to get to before. You remember that in the previous scaling, we didn't actually see the number 12, we just saw a tick mark for 12. Something else that comes up that I'll bring up now is that students and teachers often ask, well, what if I want my rabbit to jump by something other than a whole number? Can my rabbit jump by, say, 1/2? So right now our numbers are set to show units. But if I select jump by and I go to edit and edit parameter, edit properties, I can then go to the value panel and change my precision from units to tenths. Now I can go back to the jump by value and type 0.5. When I do and press jump along, we'll see the rabbit jump each time by 1/2. So 12 jumps of 1/2 land the rabbit at 6. I also, if I drag the number line to the right, see that there are negative values along here as well. If I enter a negative value for jump by, we can see the rabbit jump to the left. So this model of ours, this jump by rabbit model, we actually use in a number of other activities that relates to positive and negative numbers. So I'm going to turn this back over to Karen now to see if there are any questions that people had about this model.
Okay, Daniel, there's 2 that I pulled out that I thought would be good for you to answer out loud. And one of them is, can you capture the data in a table? So the data, you know, if you're doing the factors of 12, for example, is there a way to capture that in a table so the kids can be recording it?
That's a good question. If I select number of jumps and jump by, I can go to number and choose tabulate. And now I see that it's entered my data, 12 jumps and jump by 0.5. If I double click on the table, it adds those numbers to my table and creates a new row. If I now change these numbers to, for instance, find another way to jump to 6, so maybe 6 jumps of size 1, and I discover that works, I can double click again on my table and add that new row of data. So we can be collecting the data of what works in a table as we go through and check various combinations of number of jumps and jump by.
Thank you. And here is another question, and this has to do with the changing the color of the rainbow when you were going up to display and changing the color. And the question was, can you build in a control where children can change the color without having to go to the display menu? Is there an easier way, I guess, to change the colors of the traces instead of going to display menu?
There are ways we could develop a slider which would change the color. We find in general that going to the display menu has not been very hard, and it's something that because many of our activities involve changing color, we want students to get used to using the Sketchpad way of doing that by going to the display menu.
Now there is a suggestion from Victoria that says, could you right-click on the traces and then change the color that way? Is that a possibility?
Once the trace has been made, you cannot change its color.
Okay.
You can.
So it has to be done prior.
You can use a mouse shortcut to be able to click on that point and bring up a sub-menu here, a context menu that would allow you to change the color directly from there, but that would involve also having to know a little bit about having to do that.
Okay. So the display menu for right now for the students is probably the most appropriate. And I think those are the only questions, because you actually answered one question about can you change the value, so you changed to a decimal form. And somebody asked about fractions, and I believe Scott said that there's other versions of the jump along for equivalent fractions, and you said positive and negative. So those seem to be the only questions, so I think we're ready to move on.
Okay, great. We'll move on now, and we'll move to our next question that we have for our poll. And this question is, have you used a hundreds chart to teach multiples? So let's all take a second and answer that question. Okay, so it looks like a little over 60% of you have, about 2/3 of you have, and this should be interesting for you to look at the model we have here for a dynamic number grid. So here we have a grid of numbers. It's not actually your traditional hundreds chart in that you'll see it goes from 1 to 120. And we have various values that we can change here along the sides. So to get a sense of what these numbers can do, one thing we can do, for example, is change the number of columns and rows in our grid. So
Daniel, can I interrupt for 2 seconds? Can you hide your control panel?
Oh, yes. Sorry.
Sorry. It's a Mac feature. It shows up as a big black box.
Thank you.
Thank you.
So we were looking at the columns and rows, and right now we have 10 columns and 12 rows. And I can go, for instance, and change the number of rows from 12 to, for example, 10. And when I do that, we now have our hundreds chart. And now that we have that, let's actually start doing some skip counting along this chart. Our count by orange number is set to 3. So let's see what that means. I'm going to press Show Orange Multiples, and let's watch what happens. So I've stopped our multiples of 3 from showing for a second. And this was a model that Scott and I actually used yesterday here in a classroom, in a 3rd grade classroom in California, in Emeryville, where we're located. And we were using this with students, and as the sketch was showing our multiples of 3, we stopped at this point and asked students to describe what kind of patterns they saw in the grid. So as students were looking at this, they noticed a number of patterns. Some students noticed that there were these diagonals of orange shaded squares, what they referred to as often staircases. Other students noticed that when they looked down the columns of this grid, that there would be one orange square shaded, then two white, one orange, then two white, etc. as they moved down the table. So we asked students at this point, can you name for us some numbers along the bottom two rows that you know are going to be multiples of 3 just by using this pattern here in the grid? Because these students didn't necessarily know whether 95 or 96 was a multiple of 3, but they were able to extend this pattern of looking at these diagonals and say, for instance, oh, 93 lies along a diagonal that starts here at 30, so I predict that that's a multiple of 3. Or if I look down this column and I realize that every fourth square is shaded and is a multiple of 3, then I might also be able to say that 93 is a multiple of 3. So we continued on with our showing orange multiples, which I'll do now. And when we were done, we again asked students to tell us what they noticed about the patterns in the grid. And one interesting observation that the young girl had was that she saw these various, what she called staircases, and said there's a very short staircase over here, this one where it only has 90 and 99 in it. And we asked her, well, that short staircase is really short, but do you think if we added more rows to the grid that that staircase would continue? So we went back over here to rows and say make the number of rows equal to 13, and the girl was able to look and say that, oh yes, this pattern, the staircase does continue with 108, 117, 126, and that it really was just the start of a staircase. Now that we filled in the grid with multiples of 3, we wanted students to think about what would happen if we changed not just the number of rows in the grid, but also the number of columns. So for instance, if I change the number of columns from 10 to 11, and I'm going to do that this time not by typing in a new number, but by selecting columns, and using my keyboard, I'm going to click the plus key to increment the value by 1 to change it from 10 to 11. And when I do that, notice several things. I'm going to go back and forth now from 10 to 11 a few times. When I change to 11, the numbers along that top row that are lit up, 3, 6, and 9, those don't change. Those stay lit up. But because I'm taking that 11 from the second row and adding it to the first, the lit numbers that I have in my second row, the 12, the 15, and the 18, those move over 1. And similarly, if I go from 11 to 10 to 9, let's watch what happens. When we go to 9, those numbers move again over to the right. We'll see that again from 10 to 9. And now we have all the multiples lying in single columns, in the 3 column, the 6 column, and the 9 column. We ask our students, can you give us a value for columns so that all of the multiples of 3 and no other numbers all lie in the same column? And that may be obvious for some of us, but they had to think about that for a while. And they suggested, let's try columns equal to 3. So I'll change that to a 3. And when I do, we see all of our multiples of 3 lying in the same column. And we can think about this for other numbers. If we had count by equals 4, what number should we use so all of our multiples of 4 lie in the same column? So if I change this, for instance, from 13 back to 10, actually I should say from 3 back to 10, we could change count by orange to, for instance, 4. And instantly, without having to break out a new grid or do any erasing, all of our multiples of 3 have now shifted to multiples of 4. And we could change the value of columns to 4 and see that all the multiples of 4 lie in a single column. Notice that there is both a count by orange and a count by blue here. In fact, let me make those different values. For instance, 4 and 5. I'm going to clear the sketch, and now I'm going to press Show Both Multiples. And students who are looking at this, it may not occur to them at first, but there's this question about, well, what's going to happen for those numbers that are simultaneously a multiple of orange and blue? So you might make your own little prediction before I press Show Both Multiples. But now let's take a look. Okay, so let's see what happened. We have all of our multiples of 4 lit up in orange, all of our multiples of 5 lit up in blue, and those numbers that were both multiples of 5 and 4, like 20, 40, 60, and 80, those lit up half orange, half blue. So with this model, students can begin to ask questions like, what numbers are common multiples of both 4 and 5? And we can see those right here. What number is the least common multiple of 4 and 5? So that's the first time that we see a square that's lit up in both orange and blue as we move along the grid. And they might ask, as before, how can we get all the common multiples of 4 and 5 to land in the same column? So if I want 20, 40, 60, 80, and 100 to be in the same column, I'm going to change columns to 20. And students really, really like this when they see that their grid extends off the screen and that suddenly it's displaying these larger numbers. In this case, we see 20, 40, 60, 80, 100 in the 20th column of our grid. If we were doing this with numbers like instead of 4 and 5, if we had, say, 5 and 13 as our two count by numbers, students could see that with 5 and 13, that if they make 65 columns, that the 65th column is where those common multiples are going to lie. So the fact that the grid is dynamic and that we can change the dimensions of it is something that's not only mathematically powerful because it allows us to explore many more grids than we would normally, it's also something that from a student motivational point of view gives this sketch a very, very high fun factor for students. And just the knowledge they have that they have the power to change the size of the grid, I just think is enormous. So I'm going to go back, though, to our 10 by 10 grid here. And I want to look at the kinds of questions we can explore with this model. So I'm going to change count by orange to 1. I'll change count by blue to, say, 7. And I'll change the number of columns to 7 as well. So now we're looking at multiples of 1, so everything is lit up orange, multiples of blue, and we can see that for 1 and 7, the least common multiple of those two numbers is 7. So what happens if we keep our count by blue equal to 7, but change our count by orange to 1, 2, 3, 4, etc. What's going to happen to our least common multiple as we do that? So if I change 1 to 2, now our least common multiple is 14. When I change 2 to 3, it moves down 1 in our column to 21. And we see it keep moving down as I make count by orange one number larger at a time. 28, 35, 42. And what's going to happen next? Well, if students are looking at this, they might say 49. But when I do this and go to 7, well, least common multiple of 7 and 7 goes back to 7. If we continue, though, to 8, we see now 56, continuing our pattern, 63, 70, but we would again hit a little bump in our pattern when we hit 14, or any multiple of 7 for our value of count by orange. So this gives you just a small sampling of what can be done with this grid. The activity that will give you the entire set of teacher notes and worksheet for, 2 activities in fact, will give you a much wider sampling of what can be done. But I would like to show you one variant of this model. Here we see the grid again, but we see just a portion of it. And in fact, we don't see the entirety of each row. And what we ask students to do is to look at this grid and first of all try to figure out how many columns are in the grid. And we see that, well, this goes from 1, and we can actually see that it's going to go all the way up to 9. So there are 9 columns in this grid. But if we didn't have 1 here as our number in this top left corner, we could also figure out the number of columns a different way by looking at any square and the square directly below it and noticing that the difference between any 2 adjacent squares in a column, 2 to 11 or 11 to 20, or any of these other columns, is equal to 9, which is equal to the number of columns. But what I'd like to do now here is to try to figure out what my values for my orange count by value and my blue value are. So what am I counting by? So I'd like all of you to play along with this, or to imagine your students and give an answer you imagine a student might give. And look at this grid for a second. Notice which numbers are shaded. And now I'm going to pull up the survey. So think about what is our value for blue and what is the value for orange. And here is our poll. And we've given you some choices. And I apologize if you can't see the grid behind this. It's a little bit unfair to be asking you to do both at the same time. But I'd like you to take the poll. Okay, so let me share the results. Looks like we had the highest percentage who said orange equals 4 and blue equals 6. And I want to keep in mind this other answer here, orange equals 4 and blue equals 3. So indeed, I picked multiples of 4 as orange, 12, 20, and 28, and multiples of blue being 6 for 12 and 30. But you shouldn't feel so bad for those of you who had count by blue equals 3. 12 and 30 are both multiples of 3. The interesting thing here in the chart is you can notice that 3 itself is not shaded in. So if count by blue was equal to 3, then we would have that as a choice. But because it's not shaded in, we can't have count by blue be equal to 3. If, however, I was to scroll up a little here and hide some more of my grid so that only this portion was showing here, well, actually, again, we'd have 21 not being shaded, so that would be another cue to us that we can't have count by blue equals 3. But what often comes up in using this model where we're showing just a portion of the grid is that the numbers that I enter for count by orange and count by blue may not be the same numbers that my partner enters, and my partner may be absolutely correct in the values that she enters. They just give another solution to the problem. So if I want to create a different problem, I can just simply go here and type in a different number for either or both of these values. For instance, count by orange equals 8. I could change the number of columns to anything I'd like for instance 5. And then it's my choice. Oh, and then I hide the values so that you don't see them. And then I can just scroll anywhere else in my model here and ask you to figure out what values I entered. And this gives students a lot of fun in being able to create challenges for each other and to give each other some really stimulating mental challenges that the computer itself may not have given them. Students might enter some numbers that were much larger than we would ever give them. So that's our dynamic number grid. And I'd like to turn back to Karen now to see what questions you've all been having as I've been talking.
Well, I think everyone's been paying attention, Daniel, because there's not a lot of questions out here. There is one thing, though. How are you changing the numbers, your values, your orange and blue values? Can you just demo how you change those?
Sure. So let's say, for instance, I'd like to change count by orange from 8 to 9. One way I can do it is simply to click here in this box, and I might do it by hitting the delete key or highlighting that number 8 and typing in its place 9, and then clicking outside the box to change that value of orange from 8 to 9. If I'm going between consecutive values, like let's say I'd like to go from orange equals 9 to orange equals 10 to orange equals 11, I could simply type those numbers, or I could use a keyboard shortcut. I can select my count by orange, and on my keyboard, to increase the value by 1, I'll hit the plus key, and as I do, the values increase from 10, 11, 12, 13, and 14 and higher. Or if I want to have that value go down by 1s, I'll just hit the minus button.
Okay. And there's no more questions that I see, though there is a comment that from Tammy Jones saying that this would be a great model to use just to help students with problem-solving strategies. So I thought that was a nice comment to add on.
Absolutely, Tammy. I think that one of the things I like best about our models that we've developed is that all of them try to move beyond, like in this case, a simple recall of multiples or factors. There's a very strong problem-solving element to them. And in fact, our very next model, which is a good segue for it, mystery number, is particularly rich in problem-solving techniques. So let me begin our next activity, which is mystery number. And in this activity, Sketchpad has chosen a number. That number is between 1 and 25. And your goal is to ask Sketchpad a series of questions and figure out what that mystery number is. So our questions are all of the form, is the mystery number a multiple of 2, 3, 4, all the way up to 12? And we'd like to see if we can guess the mystery number in as few button presses as possible. And as we move along through this, you see that maybe that's not always possible, but students certainly start with the goal of seeing if they can solve this with as few guesses as possible. So one number that students quickly come across as one that's a good question to ask is the mystery number a multiple of 2? And in this case, yes, the number is a multiple of 2. So they go to their worksheet, which I will show you here. And on the worksheet, there's a place for each of them to record the number they just picked, so multiple of 2. And they can put a check mark here or write yes or no, depending on the answer. And then they can use this list of numbers below to either circle or cross off numbers that can or can't be the mystery number. And you'll notice that rather than just write the numbers across from 1 to 25, we've actually separated the even and the odd numbers from each other, so that if we learn that in this case the mystery number is a multiple of 2, we can simply draw a line straight through the numbers from 1 to 25 and eliminate all of our odd numbers right away. So if all of you were able to give me suggestions of what to try next, I would take a suggestion. But let's try another number, and I'll choose, for instance, is the mystery number a multiple of 4? So let's see. Is it a multiple of 4? No, it's not. Now, some students might say, but wait, the mystery number was a multiple of 2. You just wasted a guess because multiples of 2 are multiples of 4 also. And this is a great time to bring up a discussion of, is that true? Are all multiples of 2 multiples of 4? Well, some of them are, like 4, 8, and 12, but 6 is a multiple of 2, and that's not a multiple of 4. So I didn't really know whether it was a multiple of 4. On the other hand, if it turned out the number was a multiple of 4, well, in that case, I do know that the number is a multiple of 2 because all multiples of 4 are multiples of 2. So there's some of that logical thinking coming into place, and it's not just an abstract question. It's a question that relates directly to this model, and it's one you want to know the answer to so that you don't have to press as many buttons. So getting back to our choices, let's try multiples of 3. I actually know the answer in this case, so I'm perhaps cheating a little. And it turns out that the number is a multiple of 2 and a multiple of 3. So if it's a multiple of 2 and 3, we know that the number is also a multiple of 6. So we don't have to check 6. So if it's a multiple of 2 and 3, it could be 6, it could be 12, it could be 18, or 24. And that's as high as it goes because the mystery number is no larger than 25. So 6, 18, 6, 12, 18, or 24. Well, if the number was, for instance, 18, how could I check that? Well, a factor of 18 is 9, and neither 6, 12, or 24 has 9 as a factor. So let's check if it's a multiple of 9. And, it is. So therefore, if it's a multiple of 2, 3, and 9, it must be 18. And yes, we got it right. So now we can ask Sketchpad simply by pressing New Puzzle to create a new challenge. And I don't even know what that number is myself. It's picked a number between 1 and 25. So there are many, many different kinds of problem-solving situations that come up here. For instance, if the number is a multiple of 7, that leaves us a choice of 7, 14, or 21. To test if the number is 21, we could ask, is the number a multiple of 3? Well, no, it's not. So it's 7 or 14. And to check if it's 14, we can ask, is it a multiple of 2? And it is. So therefore, it's 14. We also could have the case that the number, when we press these buttons, we find out it's not a multiple of 2 or 3, 4, 5, 6, 7, 8, 9, 10, 11, or wow, it's not a multiple of any of these. What could be going on here? So we know the number isn't a number either 2, 3, 4, all the way up to 12. Otherwise, we'd have an answer of yes. We know the number is not a number like 14, 15, 16, 18, 20, 22, or 24, because those numbers all have factors that are between 2 and 12. So we're left with numbers like 13, 17, 19, and 23. And let's not also forget the number could be 1. But those numbers like 13, 17, 19, and 23 all share something in common, and that's that they are prime numbers. So in this context of the game, prime numbers are one of our biggest foes because they don't allow us to solve this problem with very few button presses. So in this case, we have an emergency button, a button of last resort. And that button, when we press it, shows the sum of the digits of our mystery number. So in this case, the sum of the digits in 13, 1, and 3 is equal to 4. And none of the other possibilities, either 17, 19, 23, or 1, have a sum of digits equal to 4. So we are able to figure out the mystery number with the second clue, show sum of digits, and indeed it's 13. We have a make-your-own model here. I'm going to quickly show you this because I want to have time to show you one more model. In this version of the model, I'm going to actually hide these check marks. We can play this game in pairs, just like we did with dynamic number grids. So if all of you were turning around for a second, I could move over here to this circle, my circle labeled drag, and I could move it to a new value, say 10, and that's my mystery number for you. I would then hide the mystery number, and you as my partner could then solve this challenge, and when you were done, I could then solve your challenge, and we could have a lot of fun playing this game by creating our own challenges rather than having Sketchpad create them for us. So Karen, do we have any questions?
I have two. First one is, can you extend this model to be used for place value instead of multiples? Or is there another model that does the same type of thing but with place value?
We do have a place value model, which is game-like in the sense that students are able to change the ones, tens, or hundred place and increment each number, each digit. And the goal in that case is to be able to reach a desired target in as few button presses as possible. I can't really show that here. That activity is part of Sketchpad Lesson Link, and actually is one of my favorite activities for teaching place value because it brings in problem solving in a game-like structure.
Okay, and then there was another question that asked, can the parameters be set to be, for example, 1 to 10 instead of 1 to 25, or can they be extended past 25?
Good question, too. In this particular model, the parameters are that we're looking for a number between 1 and 25, and that the multiples are between 2 and 12. That seemed to work well for me when I was creating this game. There are, I'm sure, other ways of making the choices either more narrow or to extend this to have the range go beyond 25. If anyone actually comes up with a game for numbers other than the ones I've seen here that work on the same principle, I would be very interested to hear that because I have not come up with one that I found to be as satisfying as this.
Okay, and I think that's it for these questions. And just looking at time, Daniel, we have about 10 minutes left, so I know you wanted to make sure you at least showed the last model that you had, so we can move on to that.
Okay, I'm going to show this one very quickly because it's a new model. Right now the model just has a sketch, doesn't have an activity or teacher notes or worksheet to go with it, but I think it's a nice visual model for showing factors. So I have a number 20, and then I have a bin of all the numbers between 1 and 24, and let's watch what happens when I press dance. I'm going to stop the dance movement for a second so that it doesn't interfere with the audio. But what we've seen is that all the multiples, all the factors, I should say, of 20 came out from the corner and started to form a ring around 20 and dance around it. In fact, if I now move 20 somewhere else on my sketch, those numbers would follow it. So we see those numbers which are factors of 20. What would happen now if I change 20 to a 15? I want to see which numbers continue to dance when I change 20 to 15. So I'm going to set the numbers back in motion, and then after they start to move, I'll change 20 to 15. And let's watch what happens. So the numbers 1 and 5, both of which were factors of 20, now drift down here to 15, and we see that both of those are factors of 15 as well. So 1 and 5 are common factors of both 15 and 20. 5 is the greatest common factor. And if we were to experiment with other numbers between 1 and 24, we would see that 1 was just a dancing machine. It wants to dance with every single number. Whereas some numbers, like say if I made factors of 13, is more lonely. And it's interesting to think about prime numbers in this context, where we see just two numbers dancing around a given prime number, versus our mystery number sketch, where prime numbers came up in the context of getting no down all of these no columns. So it's a very different kind of visual model. It's one we're working on, and I'd be interested in getting people's feedback from this either now or after the webinar. I think we only have just a few minutes now, but it's yet another way of making factors and multiples both more fun and engaging, and I hope from a pedagogical point of view something that really gets students to understand them better. So that's it for me on this model.
Okay, Daniel, there's no questions that I can see. Right now, if anyone does have any questions about any of the models or anything about Sketchpad that you've seen that we can hopefully answer, please type it in now and we'll try to make sure we get to that. The only comment is from Tammy, and she wanted to know, is there a way to capture the factors prior to changing the target number? So kind of actually capturing which ones were with that original number and then before they moved, you'd have them captured, to kind of keep track of which ones came from the other.
Right. My suggestion with that very low-tech solution for now would be that Sketchpad models are incredibly enhanced when students have worksheets to go with them. So I would be asking students, just like we did on the mystery number worksheet where they could record their data, to be listing the number that we were currently looking at and to be recording on that worksheet those numbers. Another possibility is that we could use our text tool to simply type those numbers directly onto Sketchpad. Or we could have perhaps extra numbers that were sitting somewhere in the corner that we could drag ourselves and not have them be affected by the number here that we would use simply for recording purposes.
Okay, thank you. And there was also a suggestion that possibly you could trace the factors. Is that possible with that model?
We could certainly trace the
numbers.
Well, we could trace the yellow behind them. I don't necessarily know what we would get from that. That would be can't actually trace numbers themselves. We can only trace, in this case, the yellow highlight.
The yellow, okay.
So that may not be as useful.
And there's a couple other suggestions which Daniel will see when we send the feedback. So those of you who are offering some suggestions, I know he's going to be interested in reading those. Right now we are going to open it to any questions. I'm not really seeing any questions except there was a question about Sketchpad 5. If you purchased it, where do you get the special applications? And I am not quite sure. I guess, Victoria is talking about the sketches. The sketches that you are seeing Daniel use are actually new ones created by Daniel and Scott, but also most of them are coming from our Sketchpad lesson link, and that is a subscription service where we have grades 3 through 12 ready-to-use activities with student worksheets, teacher notes, available for Sketchpad. But it is a separate service, and in a minute I'm going to pull up our links, and you can get to that by going to our website, and it's keypress.com/SLL, and you can sign up for a 30-day preview and just play around with some of the activities there. And again, a reminder, you will get all of the activities that Daniel used today. You will be able to download them. They will appear on our website and also in an email follow-up to you, a link to that. So you will get all the activities you saw today as well as the recording of this webinar as well. So,
can I give a quick plug for...
Absolutely. Go, Daniel.
Okay. So in addition to Sketchpad Lesson Link, Scott and I, who's been answering your questions today, are involved in a very exciting new project with Sketchpad called the Dynamic Number Project. And that project is looking at Sketchpad activities across grades 2-8, specifically for number and early algebra. And in the sketch we'll be sending you, there's a link to our curriculum page on the web, and this is a page where we're going to be adding to it on a monthly basis, and it's a place where you can download new activities. For instance, here you see our dynamic number grids activity, and you'll have activities, worksheets, even some videos to watch where we introduce the models. And Scott and I would be incredibly interested to get your feedback on these models, because they're brand new, they're not part of Sketchpad Lesson Link yet, they're free for you to try, and the feedback we get from you will be enormously helpful as we work these into the level of quality we currently have for our Sketchpad Lesson Link activities that we published. So, great way to get some free activities. Check back here often, send us feedback.
Okay, well, thank you, Daniel, very much, and thanks everyone for joining us. I'm not seeing any additional questions, so we are going to kind of bring this webinar to a close. A couple reminders. You will get a follow-up. It usually comes about 2 days. It takes us about 2 days to put the recording and the file of documents up on our website. You'll get an email with the link, or if you just want to remember that it is at keypress.com/webinars, where we post all of our recordings, all the documents that are attached to those, and also we list all of our future webinars. So that will be coming in a couple days, or you can just check periodically back at our site. I am going to take over control here, Daniel, so that I can start showing my PowerPoint again. So thank you very much for joining us today. We really appreciate you taking the time. Thank you, Daniel. I didn't know if you wanted to say some last minute thank yous.
Just want to thank everybody for coming. It's always a pleasure to be showing our Sketchpad models, and hope you enjoyed the session.
And there's information crossing your screen right now with some of the links. If you want to find more about Sketchpad, you don't have it, there's ways where you can see teachers using it in the classroom. The Sketchpad lesson link that contains not only some of the activities you saw today, but many more, hundreds more. You can go to our Sketchpad lesson link site, and you'll get all these links in your follow-up email. And when you leave today's webinar, there is a quick survey, about 7 questions, and it's just to give us some feedback on today's webinar. If you could tell us if you had technical problems, or give us some suggestions, or if you have any additional questions that were not answered, just send that to us, answer the survey, and we will respond to any of your questions or comments as soon as we can. So again, we really appreciate you coming. Thank you again, and we hope to see you on a future webinar. And I'm going to leave this up for just a couple minutes, but I am going to close the webinar, and that will bring up the survey for you. Or you can exit now on your own. Thank you again.
Karen, can I just say one thing
Scott,
very
go
quickly?
ahead.
I just want to thank the participants today for engaging as deeply as you did and giving us as many suggestions as you did. And I want to assure everyone who gave us a suggestion that I've noted them all, and
Excellent.
we really appreciate these good ideas.
Exactly.
So thanks very much for coming.
Thank you. Thank you, Scott. Oops.
Welcome to GoToWebinar, Web Events Made Easy.